All right, so Lab 7 is our third arena lab in this course, and we've gone from a very simple lab in Lab 5 to something where we get a little more detailed in Lab 6, and then here in Lab 7 we're going to add additional modeling detail and also show how we can style up the models so that the visualizations are more useful than just watching the entities as they get routed through these processes. So basically, if we go back to Lab 5 and we think about it, we basically built up an MM1 single channel queue. So parts arrived to a system, they went through this drilling center, which we just modeled with a single service time distribution. And so they just, entities basically arrived, and then if the drilling center was available, and there was just one unit of drilling center available, and if one was available, they went in and they waited for a certain amount of time corresponding to the modeled service that comes out of the drilling center, and then they were disposed. And if the drilling center was busy when they arrived, then they went up into this queue and waited for however long was necessary until the drilling center was to become free again. And that was our simple drilling center. Now, that leaves a lot to be desired because, of course, the drilling center is probably a complex system of sub-processes that some of which don't need to be modeled stochastically, because we kind of know how you get from one sub-process to another, and it's the same for every entity that comes through, and other ones that do need that stochastic modeling. And so, in other words, there's probably a more refined version of the drilling center that better captures all of the details of what goes on inside the drilling center. It might even be easier to build than one monolithic service time distribution for the drilling center. So then in Labs 5 and 6, kind of thinking along those lines, we said, well, let's make things a little more realistic. We're going to have multiple create blocks, creating multiple types of entities. Those entities will go through their own sub-processes that they kind of own themselves. And those things will have their own service time distributions. Those entities then might come back together and compete for resources that also have certain service time distributions, and then go through different conditional branches. These are the decide blocks, some together, and then some further separated. And so what we're seeing here is we still see that there is a create and a dispose. And so that's kind of very similar to the drilling center, but we've managed to split up the service time distribution into multiple subpaths that come together and split apart in different ways. So that now we have the modeling challenge of modeling these inputs, all these different processes, separately. But in the end, it might be a lot more realistic, and it might even be easier because maybe this process has a relatively simple distribution, like maybe just something exponential, although the massive process of going through this entire manufacturing and test center, if we were trying to model that as a single service time distribution, it might be very difficult for us to figure out that distribution. So there can actually be simplicity in expanding these distributions up. It can actually become simpler, and it certainly becomes more realistic. So then from there, we said, well, to even add more to the realism, it's a little bit, it is unrealistic to assume that the only time you spend in a manufacturing and test center is the time you're spending at those critical nodes, those processes, because it takes time to move from one spot in the center to another. I mean, there are whole postal mail operations which are based on the amount of time it takes not only for you to sort mail, but the significant part is to get from one section of the sorting center to another. And so those times really matter when you're routing all this traffic. The same thing with airports and things like that. It takes a really long time for a plane to get from one runway to a gate off to another runway. You really need to model those station transfer delays. And that was hopefully simplified in Lab 6 with these transfer elements that we could add, where we could say, based on the time between these different points in our model, then based on the distance between these different points on the model, we're going to simulate different transfer delays. And that then added, so we got delays not only due to processing, but also due to transferring. So that's good. It adds something to the model, But in some ways, it even takes something away from the visualization, because now you have entities arriving and then they disappear and they pop up elsewhere. And so the visualization is not really all that useful. So what we're trying to add in this lab is to enhance the visualization while also showing you that there's additional components to Arena that should be very useful to you, especially as you're moving into your final project. So the first thing we're going to do is demo this Model 5.3 from Chapter 5, which is a model of a call center. I really like this call center because so this is sort of a picture of it. It's probably very difficult to read at this scale, but hopefully you can see on the left-hand side, you've got all of these visualizations. On the right-hand side, you've got the basic model, and it's been colored nicely so you can kind of tell which chunks of the model correspond to what. So, like I said, on the left-hand side here, notice that they've taken all the cues that are of interest and they've dragged them into one area. So you may not have realized that, but when you do a seize in a process module in Arena, it creates that little queue for you, this little T-shaped thing where entities can queue up in. Well, you can actually click on that and drag that around, and so you can put them all into one nice area here so they don't have to be floating above these blocks, if that's better. So you can do that. And we'll see there's even other times where queues are created, but they're never actually used. So you can actually delete those things. And so we'll see how that works. You can add plots directly to the model so that as the model's running, you get real-time data, as you can see right here in this plot. So you don't have to wait for the reports module to start getting an idea of how the model is flowing. And sometimes seeing the model run in real time gives you more insight into how the model works, as opposed to just looking at these aggregated statistics in the reports. They've also have into the visualization here, they show all of their main resources, which are these support representatives. And so these support representatives are shown by these icons, or people sitting behind a desk with a little telephone, and they can depict whether those representatives are busy, whether they're idle, and even whether they're gone because they're just not on the schedule. So they're potentially there, but because they're not scheduled to work, they're not actually there. What you've also seen them depict here is how they've been cross-trained. So in this model, I'll show you how to use something new, resource sets, to implement cross-training. And this is something you might definitely use in your final project. And so what's being depicted here is we have 11 resources, and some of those resources have been trained on product 1, so they can take support calls on product 1. Others resources have been trained on product 2, so these two have only been trained on product 1, these two have only been trained on product 2, but these two down here have been trained on all 3 products. So we only have 11 resources, but we can divide them up into overlapping sets, and then we can actually ask for resources from those sets. And that allows us to implement cross-training. And I'll get into that into more detail. So basically, in summary, what we're trying to show you here is that you can add a bunch of visualizations right to the model, and you're going to get to practice that in the exercise for this lab. And you can create these resource sets that are often used to model cross-training. And then something else that we'll show you how to do is that right now we've shown you how to take a resource, do a seize, a delay, and a release all in one block. But sometimes you need to actually make the logic of the delay more complex than you can capture in one block. And so you can actually separate the seize and the release from each other and make a complicated delay logic in between. And we'll show you how that's done here as well. So, a background of this model is it's a call center. A call center, you can think of it as having this thing called a trunk line coming into it. Now, a trunk line is like a phone line you order from the phone company that has a greater capacity than your standard phone line. So a standard phone line, one telephone number, one line. If you call that number and somebody's using the phone, you might get a busy signal. Now, of course, call waiting, it enhances the capacity there. And so this is like taking call waiting to an extreme. So imagine if you buy this trunk line from the telephone company and it's got actually 26 slots available before someone gets a busy signal, and you can actually handle all those slots in parallel. Well, that's what we have here. So someone calls, they end up taking up a slot on the trunk line, but if there are no slots available, they get a busy signal. So that's what they'll simulate in this gray box up here, which is kind of an extended version of a create module. Now, once those customers come in, they'll then get routed based on their call type. So some customers will be calling based on for tech support. Some customers will be calling for sales. They want to buy something new. Some customers will be calling about the order status. They've already bought something and they want to see where it is or how far along it is. Now, those different types of calls can be further partitioned by the types of product. So tech support, for example, product 1 might be a very different support process than product 2 and 3. And so we need to accurately model that. Similar for things like order status. So that's why you see a bunch of these decide blocks, because they keep partitioning and then repartitioning based on these types. Now, on the resource side of things, I've mentioned there are 11 resources. Their availability varies with schedule. You've already seen how to do that in Lab 6. But on top of that, they've been cross-trained. And I've mentioned that we've implemented cross-training with something called resource sets, which I will show you in a second in Arena. So there's no simple service time distribution that can describe this whole process of getting served. So we break it up into these sort of sub-processes, but really in the end, we're just simulating something which isn't that much different than this simple drilling center. This gray block here, part arriving to the systems, that's callers arriving. If they make it through, if the trunk line has spots available, they'll go through. And then this multicolored background behind the drilling center, well, I've basically just taken the drilling center and I have refined it to capture all of the sub-processes that go on inside the center, in this case a call center instead of a drilling center. And then when they leave the system, yeah, it's true that the dispose logic here is a little more complicated than the drilling center, but it's still pretty simple. They just kind of need a spot to leave. So it looks complicated here, but really you can partition it, you can compartmentalize a bunch of these blocks as major cells here, and then those major cells kind of bring things back into a conceptualization that looks just like the drilling center that you built in that first lab, Lab 5. Okay, so what I like to do is, since I've got this video here, let's go back into Arena and take a closer look at this model. So I am going to move me out of the way here. And so this is the call center model in Arena. So hopefully it's a little more readable than it was in that PowerPoint. So if I were to run this call center model, then we can see a lot of interesting things happening with the visualization. If I slow it down, then you can still see callers arriving and going through the process the same way you're already familiar with. But if I speed it up, it'll be more clear here that now we actually have data that is being graphed in real time, and that's something that you'll end up implementing in the lab experience today. All of the queues are over here, and if I were to pause this, I can see that they've actually decorated these queues so that the entities that queue up are actually identified with their type. So notice, and here in this offline back office research, where it says there are 4 that are currently in the queue, that there are 3 of them are there for product 3 and 1 of them are for product 2. And so they use the icons to indicate what type of product is currently being served. So up here, when these queues are only for product 1, that's why we only see 1s here, and product 2, 2s here, and product 3, 3s here. Down here, they get mixed. So that can be kind of useful. And then there's a bunch of other visualizations here that show us the status of the different people that are available to, say, take sales calls, the status of the support representatives, and so on. Now, I mentioned that these support representatives are partitioned by a resource set. I'll get to that here in a little bit when I get to that in the slide here. So if I were to continue to play here, then like we said, we see them passing through. And if I look at our resources here, you can notice that if I can maybe find a way to pause at the right time, we get different times at which there. So like here, we can see that they have shown that Sammy isn't at work. Charity is at work, but she's idle. Noah is at work and busy. So very useful representations of how these entities are working. And if you look closely at how these assign blocks are, you can see that they assign different pictures at different critical points throughout the simulation here. So assign entity picture, for example. We've got assign entity picture. So at different points along here, they're assigning different pictures, and then those end up changing the visualizations as well over here. So that's some of the magic of how these things are working. All right, so let's move on through the slides here. So I want to focus now on this arrival process, which is kind of like the gray arrival process in the drilling center, but it's just being broken up. So calls arrive according to some distribution. We go through a record block, and then here's where things start getting different and kind of interesting. So I mentioned that trunk line is a resource that has a capacity of 26. So there's 26 calls that can be taken in parallel, but the trunk line doesn't have a queue. It's not like you can wait if the trunk line's full. If the trunk line's full, you get a busy signal and you're rejected. So that's what they've implemented with logic, which I'll show you here in a second. Basically, you ask, are there spots available? Is the utilization under 100%? If it is, allow the call to go through and seize one more slot in the 26 slot trunk line, and then keep moving on after that. If all 26 slots are taken up, then send a busy signal. Basically dispose of the call immediately. Now let's see how they did that. If I were to drill down into this trunk line available, I see there's an expression, NR trunk line less than MR trunk line. Now that's not very readable, but if I were to go into the expression builder, so under tools, expression builder, and if I were then to go under resource and look under usage and click under current number scheduled, then that's where I see this MR that we saw. And so current number scheduled here, this basically says for that resource how many are currently available. So in lab 6 you showed how to change the capacity schedule. This allows you to pull that capacity schedule out and say currently at this instant how many resources are scheduled. Then if I look down here and I say, all right, well in current number busy, that's the NR. So that way you can say, okay, how many resources are currently being used? So NR is how many are currently used, and MR is how many are currently scheduled to be available right now. So if I look at that trunk line available, it says the expression is NR trunk line less than MR. So it's basically saying this is how many are available, this is how many are in use if there's daylight between the two of those. So if there's still some available, then allow the call to go through. Otherwise, you're at 100% utilization and then reject it. Now notice that this logic prevents this resource from ever queuing up because we reject entities before they even have an opportunity to queue up. And that's why, even though this sees technically has a queue associated with it, they've deleted the queue visualization because that queue will always be empty. They're not using that queue even though they've seized a finite resource. So that goes what's on there. Now this whole block here, so this gray block that was behind there, apparently I can't undo that move. Oh, because I'm running. This gray block that's behind there is just drawn on for aesthetics. It's not an actual block. Now for your final project, we're going to ask you to create submodules whenever you have an opportunity for that. So what's a submodule? If I highlight a group of blocks like this one, then I can go up under Object and then go to Submodel and say Aggregate. And it will then create this submodel down here. If I click Open Submodel, I see all those elements that were aggregated together. And if I then right-click and go to Close Submodel, it brings it back out. And you can then rename these. So I could call this arrival logic or something like that. And then so you could imagine that you take all these complicated blocks here and you put them into submodels, and then suddenly they start looking a lot like the drill center. So if it's easier to depict your model to your stakeholder in a sort of hierarchical level where you just want to show a bunch of major blocks and then drill down into them, so that you can then show, well, if you're interested in how the arrival logic works, then here we can drill down into it and show you that. But most people may only care, they just trust that you've already done this detailed stuff, and they don't really care about all of that. They just care to know that arrivals came out of here. And so that's where we can create submodels to do that. So if it'll let me, which it looks like it's not going to let me in this case, but that should be okay. If I hit play, then it should still work here. So pretend like that is that old arrival logic there, and know that I could do the same thing with the rest of these. All right, so let's go back here. So that was and again, so if I were to drill down into here, then I would just see a seize and not a seize delay release, or a seize delay with a 0 delay. All right, so then the next section is when it comes out of this spot here, it comes down, and you need to decide based on call type what type of call or what block to route them in next. And so this is just by probability. 76% of the time it's a tech support call, another 16% of the time it's a sales call, and then the rest ends up being an order status call. So that's just what they've implemented here. And then they go into these different sub-blocks. So if I go back, so the decide block sorts them all out. And then they go through these. And then I'm not going to go into great detail here, but I just want to point out that each one of these processes, that's where that input modeling has gone on. So each one of these processes has a different distribution of time. So it could be, in this case, I think it's a Weibull distribution for each one of these different ones here. So there might be a product type 1 has a Weibull distribution with a certain mean and shape parameter. This one has another, 2 parameters for the Weibull. This has another 2 parameters for the Weibull. So different products take different amount of time to provide support. And then there might be some excess wait time slop that kind of is similar to the transfer time, and then we have to then decide, do you need to return their call because you have to do back office research, or do you are they completed and you can want them to be released? And so this is another thing where it's slightly different. So I've had the separate C's, which was up in that arrival process. And then now in this process, I need to release in order to make space available in that trunk line. Again, the trunk line is kind of like the muffin oven. And so when I'm done with a batch, I need to open that up so that that capacity is available to take calls again. Now, if my call has been completed, I can then release them, release one unit from the trunk line and dispose of the caller. Now, what if, from that tech support, I'm done with the caller for now because I need to do work on the side, but I don't need the caller to wait on me, and I tell the caller that I just want to call them back. So what they do here is they end up sending them into this block where we release a unit of that trunk line, and then we actually still keep the support representative busy doing the back office work. And that back office work, takes a certain amount of time and then will require calling the customer back. Now, these return calls, these resources need trunk line as well, and they do have queues. And so you might do back office research, and then you have to wait on a unit of trunk line to become available. If the trunk line's all the way full, then you grab that and call the customer back, and that's what's being modeled here. And then finally, after the customer's been called back, you can release the resource, release the tech support agent, so that they can go and end up helping more support calls. So it's a very complex way of managing these two resources, the trunk line as well as the tech support agents, but it shows the power of this simulation framework to capture these realistic process flows and how you might do that. Now, the last thing that I want to demonstrate here is this idea of these resource sets. So let me see if I think I might have a slide for these resource sets. Yes. So if we look in this pink section here, that for the tech support entities, we notice that we come in, we try to figure out which product they want, and then we assign them to the tech support representative that knows how to use that product. Now, I mentioned that in the ARENA model, some of the resources only know how to give support for one product, where other resources can give support for all three products. So how do we simulate that? Well, if we look at the, say, product one, so let me see if I can get myself out of the way here. So if I look at the product one process here, you should notice something a little different from the seize delay releases you've already used. Notice here that under resources, it says set there. So if I hit edit, it says type set. So far, you've only done type resource, but now you do type set. It's a resource set, and it has a name product one. And so if I then go over in my basic process here and I scroll down, I can find there's a set data module, and this shows all of the types of resource sets. And notice these resource sets, product one, if I drill into it, so if I double click on this one so that it opens it as a dialog, then I see that this set named product one has a list of resources. And those are Charity, Noah, Larry. These are all of the resources in here, or it's all the ones that can handle product one. Charity, Noah, Molly, Anna, and Sammy. Charity, Noah, Molly, Anna, and Sammy. And they also have Herman in here, but Herman is not depicted in this graph here. So there's other details here that I'm leaving out that you can read about in the book. But the idea here is I can create resources and then I can put them in sets, and they can be in multiple sets at once. So if I look at product two's resource set, then I see that in product two, Anna and Sammy also show up in product two, just like they were in product one. So if I go back to the product one set, I can see that Anna and Sammy are both in product one as well. So you can have these different resources allocated to multiple sets simultaneously. Then when you go into a seize delay release, you can seize from a set as opposed from a resource type. And it will then take whatever resource is available in that set, regardless of what type of resource it is. So this allows you to implement cross-training because you can sort of grab resources by their capabilities. And so you don't care who the resource is, you don't care what else they can do, just so long as they can do this one thing. Now there's complications here that I'm not going to go into. They're more advanced things like this selection rule. So how do you select from resources? Because you might imagine that if you have a bunch of different resources available, is it always a good idea to take the resource that can do only the thing you want, or should you take someone who can do other things as well? You know, I would think that in a lot of cases, if you need a product one representative, if you have a representative that can only do product one, you might want to take that one first. And so those types of scheduling things are captured in this selection rule, which you can read about if you click help. Inside ARENA, then it can go into under these guys here, under like prompts, under selection rule, which is down here somewhere. Then you can read about these different types of selection rules, what they do, and so on and so forth, or you can take a look in the book. I'm going to leave that out for now, but I just want you to be familiar with resource sets because cross-training comes up a lot in our final projects, and so you should be familiar with how to implement cross-training. So that's how we do it. And that's all that I'm kind of giving you here as kind of a quick, so that if you need a quick reminder of how to do these resource sets, you can see that here. You drill down into here, you allocate a set, you name the set, and then in the set you populate it with a list of resources that are going to be available in that set. All right, so then some blocks are simpler than others. So the sales calls, it looks very much, very similar to something you might see like in that drilling center example. The order status calls are not that complicated. It starts looking more like something you see in Lab 5 and Lab 6. And then this back office research, so this comes out of the tech support. These are additional things that consume the support representatives without consuming the trunk line until the support representatives need to phone the person back, in which case they need the trunk line again. So then finally, after all of that, you either come down from the back office research or you come over from the other blocks and you either release the trunk line if it hasn't been released. You don't worry about it if it already has. Take some stats and dispose of those calls. On the left-hand side, you've got these visualizations that are running in real time, as well as showing you the resources here. So you've got people that aren't available, you've got people that are idle, and you've got people that are busy. And so that is Model 5.3. It is one of the more complicated models. It would be, if you're shooting for a target for something, like if you could make your final project look like this, you'd be in excellent shape. This is a really interesting model. It captures rich dynamics of a call center. It allows you to test for lots of different things. So this is definitely something of this complexity that we'd love to see in your final project. In honesty, most final projects will be a little less complicated than this one, but aspirational goals, you might want to shoot for something that looks like this. This particular one shows you how to do resource sets, which is that cross-training, how to separate the seize and release, which we haven't seen before, and to use a large number of diverse blocks to really capture these interesting dynamics of this call center. And something that we demonstrated over here in the arena module, but is not demonstrated in the book at this level, is that you can end up simplifying the look of these things by clumping things into these submodels. All right, so I'm going to stop this video here and be sure to catch the next video, which will go over the instructions for the Lab 7 exercise, which will build off the kind of ideas that we just introduced with that call center demo.